Okay, we're going to take a look at example 2 here. This wants us to basically go through and explore the continuity of this function here. It should note the fundamental pieces here. X is a continuous function on its domain. 3 is a continuous function on its domain. So the only places that this function here might not be continuous is at these meetings here at 1 and 3. So let's take a look at those and explore those and see what we got. Basically, we'll note f of x equals x and f of x equals 3 are continuous. So the only places our piecewise defined function, capital F of x, might be discontinuous is at the jumps, or is at the places where the graph changes shape. So is at x equals 1 and x equals 3. So if we can figure out what's going on at x equals 1 and what's going on at x equals 3, if they're continuous or not, then we can say what's going on here. So I need to explore what's the two-sided limit at x equals 1. So I need to know, let's look at x, I guess we'll look at x equals 1 first. So I need to know what's the limit as x equals 1 from the left of f of x. What's the limit as x equals 1, or as x approaches 1 from the right of f of x. So if we look at the limit as x approaches 1 from the left, as you approach the function from the left, you're approaching 1 from numbers smaller than 1. So our function has this form here. So this would be x. The limit as x approaches 1 of x itself is just 1. As we approach 1 from the right, when we approach from the right, we're approaching from x is bigger than 1. So we're in the second form here. This would be the limit as x approaches 1 from the right of 3, which is 3. So here, these are not equal. So those are not equal, which means we have a jump discontinuity. So we're going to have a jump discontinuity at 1. So then let's look at what's going on at x equals 3. So since my left hand and my right hand limits, they didn't match up. My function value is at 3. I got a jump discontinuity at x equals 1. If I look at x equals 3 now to see what's going on there, the limit as x approaches 3 from the left of our function, what's going on there? And how about the limit as x approaches 3 from the right of our larger function? So we approach 3 from the left, we're approaching 3 from below, so we have the second form, which is limit as x approaches 3 from the left of just 3, which is 3. Limit as x approaches 3 from the right is, let's see here, function where x's are bigger than 3, we're in the bottom form, so this would be limit as x approaches 3 from the right of x, which we would plug 3 in and we get 3. So the two-sided limits match. That's good. Let's check what our function value is. So what is f of 3? F of 3, we would plug into the second form, which is 3. So in this case, we are continuous at 3. The limit, two-sided limit exists because the left hand and the right hand side both equal 3. So we can write the two-sided limit of f of x is equal to the function value of f of x at 3, and they both happen to equal 3. So basically, f of x is continuous everywhere except at x equals 1. And we have a jump discontinuity at x equals 1. Okay, I'm going to wrap that one up.